Hello everyone and welcome to Infinity Learn by Sri Chaitanya. I'm Ravindram and I'm going to discuss the physics portion of your LTC AIIMS exam weekend test number 16. Okay, so let's quickly begin with question number 1. First question we can see for the circuit shown in the figure, the current I will be, it's very easy. We'll apply the Kirchhoff's loop law and get the right answer for this particular question. See, so suppose this is the current I. Okay, so we start from here. So in the direction of the current there will be potential drop in the resistance, so minus 4i. Then again the drop will be in this minus I. Then here the potential will rise plus 4, again minus 1 minus I. Again potential will rise, plus 2 will be equal to 0. So you will say 4 plus 2 is 6, minus 6i is equals to 0, and from here we can say I is equals to 1 ampere. Got it? Next one is this. There are n rows each containing m cells. Okay, so there are how many rows? N rows, and each is containing a single cell like this. Okay, so how many m cells here and n rows here? So how many total resistances are internal resistance are there? See, in this particular question you will say total internal resistances will be n into m. This is how much? 24 cells or 24 internal resistances. This is number 1. Number 2, see, power will be maximum if R equivalent is equals to capital R. Now what is R equivalent? It is m times small r upon n is equals to capital R. Now what is m by n into small r is 0.5, capital R is 3, so 0.5 ones are 6. So m is equals to 6n. Okay, m is equals to 6n, so we can say that n into 6n is equals to 24, n square is equals to 4, n is equals to 2, m is equals to 12. Okay, so this is how you will get your answer. Is there any doubt? I guess no. So let's move on to the next question. Okay. Okay. So this question is understood, I guess. Now let's move on to the third question. So here they have said that each bulb has a power of 100 watts. Okay, so 100 is equals to V square by R of a single bulb. So V is how much? 220 square by R. So on solving you will say R is equals to 22 square ohms, right? Yes or no? Now, what is R equivalent? R equivalent will be equal to R by 4, because there are 4 bulbs in parallel. So 22 into 22 upon 4. 4 ones are 11, that is 121 ohms. So this is what? This is your equivalent R. Now tell me, what is the total current that is coming here? Total current will be V upon R equivalent, that is 220 upon 121, which is 11 into 20 is a 11 11s, that is 20 by 11, sorry, 20 by 11 ampere, right? Now what we need is, this is I1 and this is, right, this is I. Are you understanding? So this is the thing. So in this ammeter, technically the reading will be I. Okay, in this ammeter the reading will be I1, this is I2 will be the reading, right? Now you tell me, if I divide this circuit properly, so it will look somewhat like this. See, this is R, this is I, and this is overall R by 3. So this is I2, this is I1. So the reading is I2. The reading is I2. Now what is I2? You will say, sir, I2 into, sorry, I2 will be equals to, okay, see, the current will be in the inverse ratio of the resistances, right? So what you can do is, either you can do it like this. See, normal you can apply the logic. You can say, sir, I2 into R by 3 is equals to I1 into R. So either you can say, sir, I2 is equals to 3I1, and we know that I1 plus I2 is equals to I. Now what is I2? What is I1? I2 by 3. I2 by 3 plus I2 is equals to I. So I2 will be 3I by 4. So 3 by 4 into, what is I? 20 by 11. Okay, so 4 ones are 4 fives are. Answer will be 15 by 11 ampere. So I2 will become 1.35 amperes approx. Got it? So this is how we solve this particular question. Now, question number 4. Now they are saying that this is a Wheatstone bridge. If it is a Wheatstone bridge, so you will say that P upon R is equals to Q upon, what is the equivalent of this? Sy upon S plus Y. Now you solve it. It is 2 by 2 is equals to 2 by 3y into 3 plus y. No, 3y is equals to 6 plus 2y. So y is equals to 6. Got it? This is how you will solve it. Question number 5. Now two cells of EMF E1 and E2 are joined in series with the balancing length of potentiometer. See, E1 plus E2 in the first case, when they are connected like this, the two cells are connected in series. So overall drop will be E1 plus E2, which is equals to V by capital L, that is potential gradient, into 600. Next time one is connected in reverse polarity, so it will be V by L into 150. Can you see that? Now you take the ratio and you can get your answer. So it will be E1 plus E2 upon E1 minus E2 is equals to 600 upon 150. Okay, 151s are 154s are. So it is E1 plus E2 is equals to 4E1 minus 4E2, right? 5E2 is equals to 3E1. So answer is 5 is to 3. Got it? So this is how you solve it. Now here, length of potentiometer AB is 2 centimeter. Okay, potentiometer wire, its resistance is 4 ohms. Perfect. Okay, that means this overall is 4 ohms, right? So if I want to find out the potential gradient, how will I do that? See, the potential drop in 4 ohm resistance will be 4 into I. This is your V. So 4 into 20 upon current is what? 4 plus 6, that is equals to V. So V is equals to 8 volts. Total length is 2 meters. So V by L, potential gradient will be 8 by 2, that is 4 volt per meter, right? This is potential gradient. Now what is the new length? 1.5 meter. So E naught is equals to V by L into small l. So it will be how much? 4 into 1.5, that means 6 volts. So what is the EMF of the battery? It will be 6 volts. Is it okay? Understood, my dear students? Now this one, in the shown setup of meter bridge, there is no deflection in galvanometer, right? If there is no, the unknown resistance are, it's very simple. This is what? This is 70 centimeter because it's a meter bridge. So you will say 60 by 30 is equals to R by 70. This is formula, na? That is R1 by L1 is equals to R2 by L2. So here R1 is equals to 60 and R2 is equals to R. L1 is equals to 30 and L2 is equals to 70. So 31s are 32s are, R will be 140 ohms. Got it? Now question number 8. For measuring of potential difference, potentiometer is preferred in comparison to voltmeter. See, the only problem with the voltmeter was that it was withdrawing current from the circuit and thereby altering the actual reading that we wanted. Potentiometer is a device which does not take any current from the circuit, and hence it gives the accurate reading. That is why we prefer potentiometer over voltmeter. I'm sorry, something is there with my nose. It's constantly itching. Okay, fourth option. Okay, 9. In a potentiometer experiment, the balancing length with a cell at a length of 240 centimeter. Okay. On shunting the cell with a resistance of 2 ohm, the balancing length becomes. See, there's a direct formula for this. I don't need to draw anything. Whenever, see, the diagram will look somewhat like this. I'll just quickly tell you the diagram. This is a potentiometer wire. Okay. Now, so there will be two lengths, L1 and L2. When switch S is open, then length is L1. When it is closed, the length will be L2, which is less than that. Okay. When the switch is closed. So we say that R, small r is equals to capital R into L1 minus L2 upon L2. This we need to remember. Now what is R? 2 ohms into L1 is how much? 240 minus 120 upon 120. What is the answer? 2 ohms. Got it? This formula please remember. Then only you can solve this question, otherwise not. Okay. Sensitivity can be increased by increasing the length of the potentiometer, because see, sensitivity can be increased when potential per unit length, that is potential gradient, is lesser. Then sensitivity 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 is higher. Very sensitive word. The electric current in the circuit is, see, we can add them. 2 plus 3, 2 plus 3 is 5 ampere. 2 goes here, 3 ampere goes here, 1 ampere is coming, 4 ampere here. Fourth option is correct. I hope you understand it properly. Any doubt, please let me know. Okay, so in this next question, as you can see that there is a Wheatstone bridge formation taking place here. Wheatstone bridge is formed where? Here, between points A and B. So this resistance can be removed. Do you understand which one? This one. This can be removed. So obviously the circuit will somewhat look like this now, and its equivalent will be this, and this is your exact answer. Do you understand? Now here, this is a very important question. See, R1 is equals to R naught into 1 plus alpha into delta T1. Okay, R2 is equals to R naught into 1 plus alpha into delta T2. This is a very interesting formula. What is R1? R1 is 100 ohms. What is R2? R2 is 200 ohms. R0 and R0 will get cancelled. It will become 1 plus alpha times delta T1 is 100 minus 0, because reference temperature is 0 degree centigrade, plus next is what is the temperature we don't know, right? That we need to figure out. So if you take this formula and solve it, it will become 1 plus alpha T is equals to 2 plus 2 alpha into 100. That is, it will be alpha T is equals to 1 plus 200 alpha. So T is equals to 1 by alpha plus 200. Now what is 1 by alpha? 1 by 0.005, that is 200. So answer will be 400 degree centigrade. This is how you will get your answer. Okay, question number 14. This is a very known fact. The reason for the photodiodes are operated in reverse bias condition when light falls on it, because the fractional change in the reverse bias current is greater in that situation. Okay, so third option is correct. Full wave rectification. See, if I talk about this wave, so this is like in time t only there is one cycle, another cycle in time 2t. But when it gets rectified, so your time one cycle is completed in t by 2 only, and in time t there are two cycles, so there are two cycles in time t, so one cycle in time t by 2. So what happens, if time period is halved in full wave rectification, frequency will be doubled, right? So it will be 2n now. You understand? So if initially time period was t and frequency was n, now time period will be t by 2 and frequency will be 2n. Okay, right? Simple reason. See, time period is inversely proportional to frequency. So if you half the time period, if you cut the time period half, then the frequency will become double, right? Npn transistor. See, in a transistor, always remember that emitter base junction is forward biased and base collector junction is reversed bias. So we have to make sure this thing. What? See, this is a transistor. Now what kind of transistor this is? This is Npn. Now this is suppose your emitter, and this is suppose your base, and this is your collector. Now what you want is, you want this end, that is emitter base, to be forward biased. So n should be connected with a negative terminal and base should be connected with a positive terminal. Now you want base collector junction to be reversed bias, so this collector should have a higher potential. See, collector should have, n should have a higher potential in order to make it reverse bias, and n should have a lesser potential in order to make it forward biased. So this will be high positive as compared to base, so then it is reverse bias, right? So we will say that emitter is negative, base is positive, and collector is positive to base, and collector is positive as compared to base. Let's see whatever I'm saying, let's see if it matches somewhere or not. See, fourth option, collector is positive and emitter is negative with respect to the base. Very good. Yes, very good. That means with respect to the base, emitter should have a lesser potential and collector should have a higher potential. Simple logic. Because we want emitter base junction to be forward biased and base collector junction to be reverse biased. Clear? See, simple logic. If P in a PN junction, okay, in a PN junction, if you want to make it forward biased, so P should have higher potential as compared to N. And in a PN junction, if you want to make it reverse bias, then P should have a lower potential as compared to N. Simple logic. Now forget negative positive. Let's say a very normal logic let's use. What we want is this. In this question, see, NPN transistor, we want to find out the potential difference. See, base emitter is forward biased. If this PN junction is forward biased, which PN junction? If this PN junction is forward biased, then P should have a higher potential as compared to N. That means base should have higher potential as compared to emitter, that is for sure. Okay, so this should be greater than this, and as compared to, and now base collector junction should be reverse biased, so P should have a lower potential as compared to collector now, like N. So in between P and N, this time N will have higher potential. That means this is the scenario. So you can say emitter is, so collector is positive and emitter is negative with respect to the base. So with respect to the base, collector is positive and this is negative. This is how you will get your answer. Okay, this is one thing. Or you can say simply, for during forward bias condition, forward bias, N for negative, P for positive. during forward bias. During reverse bias, N for positive only, not negative. This is also you can do. Clear? So I have told you different methods. You can remember it like this. Now, a current gain of transistor in common emitter circuit is, what is current gain? Beta. That is IC upon IB, collector current upon base current. This is 40. The ratio of emitter current to base current is, okay. Now what do you want? What do they want is this: a ratio of emitter current to base current is, okay. Very good. See how we can do that. The current gain in a transistor is this. See, we can say that IC is IE minus IB upon IB is equals to 40. So IE upon IB minus 1 is 40. So emitter current upon base current is 41. That is what they want, and I guess the option number 2 is correct. Okay. See, electric field intensity is potential difference upon the distance. So it is 2 into 10 to the power minus 6 meter is the distance, and potential difference is 0.3. Now you can solve it and definitely get that the answer correct is third option. Okay. Now in NPN transistor, these many electrons enter the emitter in these many seconds. Enter the emitter. So what is the emitter current? It is 10 to the power 8 into 1.6 into 10 to the power minus 19 upon 10 to the power minus 8 ampere, right? Total charge upon total time. So emitter current will be 1.6 into 10 to the power minus 3 ampere. So emitter current is 1.6 milliampere, right? Now, anyways, if they would have asked this thing, then we would have done that, but I've just given you an example. Now 1% of electrons are lost in base. That means base is 1% of emitter current. So what is 99 per, what is IC? IC is remaining 99% of IE. What they need? The fraction of the current that enters the collector and the current amplification factor. See, current amplification factor is IC by IB. That is current gain, right? That is what? Current gain. So it is obviously, see, 99% of IE upon 1% of IE, right? So this is what? 99. So amplification factor is 99. Okay. And the fraction of the current that enters is C. Fraction of current in base is this. So obviously in collector will be what? Okay. So fourth option is correct. Got it? The width of the depletion layer in PN junction diode increases in forward bias. No, Baba, it decreases. Third option is correct. Why? Because A is false. If A is false, that means third option is correct. So let's go for B option also. In intrinsic semiconductor, the Fermi energy level is exactly in the middle of the forbidden gap. Yes, this is true, right? Intrinsic semiconductor means intrinsic semiconductor is undoped semiconductor, right? So in undoped semiconductor, the Fermi energy level is exactly in the middle of the forbidden gap. Okay. Now the current I in the circuit is, see here, this diode is reversed biased, so there will be no current in this branch. So this is all done. Okay. So 5 is equals to 20 plus 30 into I. So it will be 5 is equals to 50 I. So I is equals to 0.1 ampere. Got it? Now 22. Zener breakdown takes place during high impurity doping. Okay. So doped impurity should be very high, then only Zener breakdown will take place. So second option is correct. In a common emitter transistor, the current gain is 80. What is the change in collector current when the change in base current is 250 microampere? Okay, very simple. We know that delta IC upon delta IB is equals to current gain, which is 80. Yes or no? Now change in base current is 250 microampere. So delta IC will be 80 into 250 microampere. So 10 to the power minus 3 milliamperes. Okay. So what will happen? 25,800 altogether 20 milliampere. Got it? First option is correct. 24. A common emitter amplifier is designed with NPN transistor. Alpha is 0.99. Okay, alpha is 0.99. So what is current gain? That is beta. Beta is alpha upon 1 minus alpha. So 0.99 upon 1 minus 0.99, that is 0.99 upon 0.01, that is 99. Now what is this? This is your current gain. Now what is voltage gain? Remember, voltage gain is equals to current gain into resistance gain. Okay, so your answer will be beta into delta R output upon delta R input. So it will be 99 into 10 upon 1. So answer is 990 volts. Okay, sorry, 990 is the voltage gain. Got it? Now 25, in the given circuit the voltage drop across 6 ohm resistances. Simply this is reverse bias, so current will not go here. So current will come here, here, and then will pass from here. So obviously it is 12 upon 3 plus 6 into 6 is the drop. 3 plus 6 is 9. 3 4s are 3 3s are 3 1s are 3 2s are. Answer is 8 volts. Got it? Okay, the conductivity of a semiconductor increases with temperature because obviously the what happens, the number density of carriers increases because more and more electrons will now go into the conduction band. So as you increase the temperature, number of electrons in the conduction band and number of valency or number of holes in the valency band increases, and because there are more charge carriers in the conduction band and the valency band, so we can say the conduction will be more in semiconductors. Do you understand? But effect of decrease in relaxation time is much less. See what happens, there are two things in conductors. If we talk about what happens in conductors generally, and when you already there are plenty of electrons in the conduction band already, so when you increase the temperature, the electrons start colliding with each other more frequently, because of which even though they have more energy, but their collision frequency rises so much that the overall resistance increases and conduction drops. But with semiconductors, when you increase the temperature, more electrons and more charge carriers are there in the conduction band. Now since there are more charge carriers, so there will be more conduction, but there is one factor this also, that the relaxation time reduces or collision frequency increases, but this factor is not so much as compared to the factor that more electrons are there in the conduction band. Do you understand? So that is why fourth option what do you say, appropriately tells you the exact reason for the conductivity of semiconductor increases with temperature. A cell of EMF 4.5 volts is connected to a junction diode whose barrier potential is this. If the external resistance in the circuit is 190 ohm, the current in the circuit is simple. See, 4.5 minus 0.7 is equals to 190 into I. Simple reason. This is the potential barrier which is kept in between. So overall, you will say sir 3.8 is equals to 190 into I, and your answer will be 20 milliampere. Do you understand, everyone? In a thermodynamic process, the pressure of a fixed mass of a gas is changed in such a way that the gas releases. See, first law says that delta Q is delta U plus W. Energy is, so what they're saying is, released 40 joules of heat is released, so negative 40. Final potential energy is U, minus initial is 20. Work done will be minus 30 because work is not done by the gas, work is done on the gas. That is taken negative. So U is equals to 10 joules. Do you understand? Now let's come to question number 29 quickly. See, this rate, it is 1 minus T2 by T1. So if you say that efficient, what will be the new efficiency if the source and sink temperatures are doubled? If both of them are doubled, then it doesn't affect the efficiency. 30. Okay, the temperature of this option is wrong. The temperature of 5 moles of gas, okay, so in this question everybody would say that 4 is not the option, 0.8 is the correct answer. Why? Because you are solving it and you are getting it answer, right? Right. But see, in the question they are asking the total heat capacity, they are not asking specific heat capacity. Actually this is wrong and this is right, because they are not asking CV, they are asking NCV. This is known as heat, total heat capacity. So 5 into 0.8, answer will be 4. So this is the specific, because they have not said joule per mole per Kelvin. Have they given that? They have just given joule per Kelvin. Yes, they are not saying joule per mole per Kelvin. Then it would have been specific heat capacity, specific molar heat capacity. But they are just asking total heat capacity. That means they are asking NCV. Okay, now COP. What is the formula COP? Can you tell me? The formula for COP is very simple. It is T2 upon T1 minus T2. T2 is the lower temperature. So it is 250 Kelvin upon 300 minus 250 Kelvin. Right? So it is 5. This is the COP, coefficient of performance for a refrigerator. Right? Now, the internal energy U is a point function, in fact not a path function, because it does not depend upon path. Simple, it depends upon points. That means it's a state variable. No, it's not a path variable, it's a state variable. So it depends upon this thing. It does not depend upon the path, it depends upon the points or the states, initial and final states. 1 mole of an atomic gas is mixed with another 1 mole of diatomic gas. What will be the gamma? See, there's a simple formula, N1 plus N2 upon gamma of the mixture minus 1 is equals to N1 upon gamma 1 minus 1 plus N2 upon gamma 2 minus 1. Is it clear? Is it clear or not? This is how it will be. So diatomic gas at a pressure P and volume V is compressed adiabatically. Simple formula, PV to the power gamma is constant. We will use that. What is gamma for diatomic gas? It is 7 by 5. Sorry, 7 by 5. So you say P1 V1 to the power gamma is equals to P2 V2 to the power gamma. Now you solve it, you will get this answer, right? Now, all heat can be converted into work is wrong. Efficiency of a heat engine is always lesser than unity, right? It is not possible to transfer heat from lower to absolutely. This is second law, right? So technically this is the first law, this is the second law, right? And this is the violation of the first law. So both B and C are true. Cell of EMF 12 volt and having some internal resistance supplies currents for some time t through external resistance 1 ohm and 4 ohm separately. If heat developed in the external resistance in two cases is the same. Acha. Okay, see. First case current is I1 square into R1. They are saying I2 square into R2. They are same. Now what is I1? I1 is 12 upon 1 plus small r whole square into 1 is equals to 12 upon 4 plus small r whole square into 4. Now taking under root both sides, 12 and 12 will get cancelled. 1 by 1 plus r is equals to 1 by 4 plus r. Under root of 4 will be 2, right? So you will say 4 plus r is equals to 2 plus 2r. So 2 is equals to R, so R is equals to 2 ohms. Got it? Yes. So R will be 2 ohms. 37. Now this is very simple question. See, they want the potential difference between point A and B. Very simple. First of all, find out the current in the circuit, right? So it will be from here minus 8 drop, minus 1.5 I is the drop, minus 0.5 I is the drop, plus 12 is the rise. This is 0. So what is the value of I? Just tell me. We will say 4 is equals to 2I. So I is equals to 2 ampere. Now I is equals to 2 ampere. You know that. So what is the drop? You will say VA minus 12, right? But the current is in this direction. Okay. So plus zero point 0.5 I is equals to VB. Why? Because in if the current is in this direction but you are going in a resistor opposite to current, the potential rises, not drops. Okay, so VA minus VB is equals to 12 minus 1, that is 11. So answer is 11 volts. Okay, so first option is correct. 38. P by Q is 1. Find the shift in the null point if P is doubled and Q is halved. See, let's say initially when P by Q is 1 and 1 by 1, that means initially length was 50 centimeter, right? Now if P is doubled and Q is halved, then the ratio becomes 4 times P by Q, right? Do you understand? Or let me see, what can I do is, see, we will say that, see, P upon L1 is equals to Q upon 100 minus L1. Okay, if P by Q is 1, if P by Q is 1, then L1 is equals to 50 centimeter, right? Now they are saying that it is 2P and it is Q by 2. So it will be L2 upon 100 minus L2, right? Now what will it be? P and Q are same, but it will become 400 minus 4L2 is equals to L2. So L2 is equals to 80 centimeter. So what is the shift? L2 minus L1 is equals to 30 centimeter is the shift. That is why fourth option is correct. Okay. Now question number 39. It's very easy. In a meter bridge, gaps are closed by two resistances P and Q. Just now we have done this kind of question, right? So initially they are saying that P by 40 is equals to Q by 60. Number one. Next time, if Q is shunted by resistance of 10 ohm, that means one resistance of 10 ohms is connected in parallel, then the balance point shifts to 50 centimeter. That means P by 50 is equals to 10Q upon 10 plus Q. This is the overall resistance here upon 50. Why? Because this time it is here 50-50. So you will say P is equals to 2Q by 3. Okay, P is equals to 2Q by 3 is equals to 10Q upon 10 plus Q. So Q and Q gets cancelled. 2 ones are 2 fives are 15. 5 threes are 15. So Q is equals to 5. Q is equals to 5 and P is equals to 10 by 3. Got it? So I guess first option is correct. Done. Let's come to question number 40. This is very simple. VA minus 2 into 1, then potential rise plus 5 minus 1 into 1 is equals to VB. So what is VA minus VB? Minus 2 minus 5, 0. VA minus VB will come out to be 0. I'm sorry students. Question number 41. This is very interesting. See, this is 2 ohms, this is 3 ohms, this is 3 ohms, this is 2 ohms. So basically 2 ampere is coming and this is 5 ohms and this is 5 ohms. Obviously current will divide, 1 ampere here, 1 ampere here. Now if you look at the circuit again, so here 1 ampere is going in 2 ohms, and here 1 ampere is going in 3 ohms. So here the potential will drop by, here the potential will drop by 2 volts, and here the potential will drop by 3 volts. So obviously the potential difference between A and B will be 1 volt. That means A is 1 volt higher than B, right? A is 1 volt higher than B. Let's come to question number 42. In question number 42, there's a very simple logic that we need to use. They have given current I, which is equals to dq by dt. If you want to know total amount of charge that has passed, dq will be equals to I dt. Simple. I is what? 4 plus 2t. And you simply do the integration, put the limits from 2 seconds to 6 seconds, right? That is all. You will get the answer. Simple. Now question number 43. See, if this is a Zener diode, that means it maintains the constant potential difference across its terminals no matter what is the current. So this is 50 volts. So what is the current that can go through this? It will be how much? Current, let's say that is I1. So I1 will be 50 upon 20 kilo ohms. So it will become 2.5 milliampere. Now what is the current? What is the potential drop here? Here will be 150 volts drop if 50 is dropped here. So what is the current here? You will say I2. So I2 is equals to 150 upon 5, that is 30 milliampere. So what is the current going in the Zener diode? Whatever is remaining, that is I2 minus I1. So it is 27.5 milliampere. Do you understand? Question number 44. It's very easy. Energy gap is given, the wavelength is asked. Lambda is equals to 12400, okay, electron volts upon, what is this? Sorry, 12400 upon energy in electron volts, that is 1.9. Answer will be in angstroms. Do this, your answer will come out to be 6540 angstrom or 654 nanometer. Do you understand? 6540 angstroms it comes, or it is 654 nanometer. So very carefully choose your answer, right? 45. See, if in the following figure, if germanium diode is reversed, see, first of all, germanium is forward biased, silicon is forward biased. So germanium works at 0.3 volts. So what will happen? Germanium works at 0.3 volts, so it will allow all the current to pass through it, right? Silicon is still working at 0.3 volts, but it is not allowing all the current. So whatever current is there, it will pass through germanium, and the overall drop here will be 0.3 volts, right? So what is the value of V naught? You will say 12 minus 0.3 is equals to V naught in the first case, that is 11.7 volts, right? In the next case, what will happen if you connect it in reverse biased? So no matter what, germanium will not open, but after 0.7 volts, silicon will completely allow all the current. So the potential difference will be maintained 0.7 volts. So this time 12 minus 0.7 will be V naught, second value, that is 11.3 volts, right? So what is this difference in the values of V naught in both the cases? 0.4 volts. Do you understand? See, first of all, both are forward biased. So germanium will, see, these are the knee point temperature, potential values. See, if you remember the IV characteristic, this happens, okay? So this is the knee point. This is 0.3 volts for germanium and 0.7 for silicon. So after this particular potential difference, it starts conducting all the current without any significant change in potential drop. So once the potential drop is more than 0.3 volts in germanium, it will allow all the current to pass through it, and its potential drop will become overall constant. Okay, so between 0.3 and 0.7, 0.3 has a lesser value, that is why it will hold first. But in the next case, what we are doing, we are reversing the germanium, right? Once the germanium is reversed, then what will happen? No matter what is the potential drop, it will not break. So all the current has to pass through silicon, and silicon will allow all the current without any significant change in potential drop once it has reached the value of 0.7 volts. Once the value of 0.7 volt is reached in silicon, it will allow all the current without any significant change in its potential drop. That is why I am saying that in the second case, the overall potential drop in this particular branch becomes 0.7 volts, because of which we will say now V naught in the second case is 11.3 volts. Got it? In a common emitter amplifier is designed with an NPN transistor, alpha is 0.99. The input resistance, okay. I guess this question is repeated because we just now did. Find out beta. It is alpha upon 1 minus alpha, and voltage gain is equals to beta into resistance gain. Okay, voltage gain is equals to beta into resistance gain. Beta will be 99 and resistance gain will be 10 upon 1. So answer will be 990. Understood? Question number 47. In an NPN transistor, current gain for common emitter is 80. So beta is 80. The emitter current be 8.1 milliampere. The base current is simple. IC upon IB is 80. IE minus IB upon IB is 80. So IE upon IB is 81. 8.1 milliampere is equals to 81 into IB. So IB will be 0.1 milliampere. Got it? Now here obviously we need to think correct transistor biasing is. See, this is emitter, this is base, and this is collector. Emitter versus base should be forward biased. Emitter should have higher potential, B should have a lower potential. Collector base should be reverse bias. So B should have a higher potential and collector should have a lower potential. So this is correct. Okay. 49. This is very simple. In an isothermal expansion, see what is the work done? nRT ln V2 upon V1. That's all. So the ratio V2 by V1 is same in both the cases, only temperature is getting doubled. That is why the work will be 2W. See, initially it is this W1 is W. W2 is what? NR into 2T. The ratio is still same. The ratio is still same. What is the ratio? V2 by V1. You will say it is 5 by 2. Next time it is 25 by 10. Both are same, 5 by 2 only. So since the temperature is getting doubled, so work becomes double. Okay. Last question. Here the answer will be the area of this circle. So it is pi r1 r2. R1 is the radius for the vertical axis. R2 is the radius from the horizontal axis. From the vertical axis it will be 30 minus 10, that is 20 by 2 is 10. So it is 10 into 10 to the power minus 3 meter cube into horizontal axis will be 30 minus 10 is 20 by 2 is 10 is the radius into 10 to the power 3 kilopascals. So pascals. So it will become 100 pi joules, that is 10 to the power 2 pi joules. Okay students, so that is all for today from my side, and I hope that you have understood every question properly, and these solutions must have helped you in revising these particular chapters. So good luck to all of you, all the best for your examinations and for the next exam as well. Thank you so much. Please subscribe to our channel and come and visit our platform as many times as possible. So this is me, Ravindram. Thank you so much.